If you are over 50 and you have noticed that your memory is not quite what it used to be, that names slip away before you can hold on to them, that you walk into a room and forget why you came, that conversations from last week feel strangely distant, I want you to stay with me for the next few minutes, because what I'm about to share with you is something I have spent 3 decades studying, and it is something that most doctors will never bring up during a routine appointment. Not because they are hiding it from you, but because the research is newer than most medical training, and because the honest answer requires more time than a 15-minute checkup allows. My name is Dr. Marcus Reid. I spent 30 years at the intersection of neurology and aging research, and the single most consistent finding across that entire career is this: the brain does not decline randomly. It declines in response to specific inputs. And one of the most damaging of those inputs is something that the majority of Americans over 50 consume every single day, often multiple times a day, without any awareness of what it is doing to the tissue inside their skull. I am going to tell you exactly what that food is. But before I do, I need you to understand why it causes the damage it causes. Because if you understand the mechanism, you will never look at this food the same way again. And that understanding is what will actually change your behavior. Not a list, not a warning label, but a clear picture of what is happening inside your brain every time you consume it. Let me start with something fundamental about how your brain works. Your brain is the most metabolically active organ in your body. It represents roughly 2% of your body weight but consumes approximately 20% of your total energy. It is running constantly, processing sensory input, consolidating memories, regulating hormones, managing every system in your body simultaneously. And to do all of that, it depends on a continuous, stable supply of fuel. That fuel, primarily, is glucose, blood sugar, the same substance that your body derives from the carbohydrates and sugars in everything you eat. Now here is where it gets important. The brain does not simply need glucose. It needs glucose delivered in a specific way, steadily, consistently, without dramatic spikes and crashes. The neurons in your brain, the cells responsible for memory formation, for cognitive processing, for everything you think of as your mental sharpness, are extraordinarily sensitive to fluctuations in that fuel supply. When blood sugar spikes sharply and then crashes, neurons do not simply slow down. They become stressed. They produce inflammatory compounds. They become less efficient at forming and retrieving memories. And over time, with repeated exposure to these cycles of spike and crash, they begin to sustain damage that accumulates quietly, invisibly, for years before it becomes noticeable. This process has a name in the neuroscience literature. Researchers studying the intersection of metabolic health and cognitive decline have begun referring to Alzheimer's disease and related dementias as, in some contexts, a metabolic disorder of the brain. Some researchers have gone so far as to use the term type 3 diabetes, not as a formal clinical diagnosis, but as a way of describing the relationship between insulin resistance in brain tissue and the progressive loss of cognitive function. I want to be clear about something here. This does not mean that everyone who eats poorly will develop dementia. The relationship between diet and cognitive decline is probabilistic, not deterministic. But what the research does show, consistently and across multiple large population studies, is that chronic exposure to rapid blood sugar spikes accelerates the biological processes associated with memory loss and cognitive decline, and that this acceleration begins well before any symptoms are noticeable. Which brings me to the food. The single food category most consistently associated with this pattern of damage, the one that produces the most dramatic blood sugar spikes, the most severe inflammatory response in brain tissue, and the most significant long-term risk to cognitive function in adults over 50, is ultra-processed sugar. Specifically, the added refined sugar found in a category of foods that most Americans consume daily without thinking of them as particularly dangerous. I am not talking about natural sugars found in whole fruit. The fiber in whole fruit significantly modulates how quickly its sugar enters your bloodstream. I am not talking about the occasional dessert at a family dinner. I am talking about the systematic, daily, repeated consumption of foods engineered to deliver concentrated refined sugar directly into your bloodstream as rapidly as possible. The specific culprits are things you already recognize: sweetened beverages, sodas, fruit juices, sweetened coffees, energy drinks, packaged breakfast foods, cereals, flavored yogurts, granola bars marketed as healthy, baked goods, muffins, pastries, cookies, the kind of thing that sits on a counter at a coffee shop and looks harmless, flavored condiments, ketchup, barbecue sauce, salad dressings that carry surprising amounts of added sugar, and the category that catches most people off guard: processed snack foods that combine refined sugar with refined carbohydrates in a way that produces blood sugar responses even more extreme than sugar alone. Every time you consume these foods, here is what happens inside your brain. Within minutes of ingestion, your blood glucose rises sharply. Your pancreas responds by releasing insulin to manage that glucose. If this happens occasionally, your body handles it efficiently. But if it happens 3, 4, 5 times a day, which is entirely typical for the average American diet, your cells begin to develop insulin resistance. They stop responding normally to insulin signals. Glucose cannot enter cells efficiently, and in brain tissue, this insulin resistance has a specific and particularly damaging consequence. Insulin in the brain does not simply manage glucose. It also plays a critical role in the clearance of amyloid beta, the protein fragment that, when it accumulates in excessive amounts, forms the plaques associated with Alzheimer's disease. When insulin signaling in brain tissue is disrupted by chronic insulin resistance, amyloid clearance is impaired. The protein accumulates more rapidly than it is cleared, and the biological foundation for cognitive decline is being laid, silently, years or even decades before any memory symptom appears. There is a second mechanism that operates in parallel. Chronic blood sugar spikes promote systemic inflammation. Inflammatory markers cross the blood-brain barrier and trigger neuroinflammation, inflammation within brain tissue itself. Neuroinflammation damages the hippocampus, the structure most directly responsible for the formation of new memories. It impairs the function of the synaptic connections between neurons, the connections across which memories are encoded and retrieved, and it accelerates the rate at which neurons age and, eventually, die. This is why people over 50 often describe a gradual sense that their memory is becoming less reliable, not a sudden loss, a slow, progressive dimming. Names that used to come instantly now require a moment. Details that used to be vivid are now slightly blurred. That experience is not simply aging. It is, in a significant proportion of cases, the accumulated neurological cost of years of repeated blood sugar dysregulation. Now let me tell you what the research shows about reversal, because this is the part that most people do not hear, and it is the most important part of this conversation. The brain is not a static organ. It is not simply declining, and there is nothing to be done. The adult brain retains a remarkable capacity for adaptation and repair, a capacity that neuroscientists call neuroplasticity. And one of the most powerful levers for activating that capacity is the reduction of chronic blood sugar dysregulation. Multiple studies have examined what happens to cognitive function when adults significantly reduce their intake of ultra-processed sugar and refined carbohydrates. The findings are consistent. Within weeks, markers of neuroinflammation begin to decline. Within months, measures of memory and cognitive processing speed show measurable improvement. And in longer-term studies, the rate of cognitive decline in adults who maintain stable blood sugar levels is significantly lower than in those who do not. This does not mean eliminating all sugar from your life. It does not mean a rigid or joyless approach to eating. It means becoming aware of the specific foods that are producing the most damaging blood sugar responses in your body, and systematically reducing your exposure to them. The practical starting point is simpler than most people expect. Remove sweetened beverages entirely. They are the single highest impact change you can make because liquid sugar reaches your bloodstream faster than almost any other form. Replace them with water, unsweetened tea, or black coffee. That single change, maintained consistently, will reduce your daily blood sugar spike burden more than almost any other dietary modification. The second step is to read labels on packaged foods with one specific focus: added sugar content. Not total carbohydrates, not calories, added sugar. The American Heart Association recommends no more than 25 grams of added sugar per day for women and 36 grams for men. The average American consumes approximately 77 grams per day. The gap between those numbers is where the damage is occurring. The third step is to prioritize foods that actively support brain health, foods that provide stable, sustained fuel without triggering the spike and crash cycle. Whole vegetables, legumes, fatty fish rich in omega-3 fatty acids, which have their own direct neuroprotective effects. Nuts and seeds, eggs, foods that your grandmother would have recognized as food. These are not exotic interventions. They are not expensive supplements or complicated protocols. They are the basic nutritional conditions under which the human brain evolved to function, and conditions that the modern processed food environment has systematically disrupted. I want to leave you with something that I tell every patient who sits across from me when this conversation comes up. The changes happening in your brain right now are not inevitable. They are not simply the price of getting older. They are, in significant part, the consequence of specific inputs. Inputs that can be changed, reduced, and in many cases reversed. The research on this is clear. The mechanism is understood. And the window to act, the window during which dietary change can produce meaningful neurological benefit, is open right now, while you are watching this, while you are thinking about it. The brain you have at 70 will be built in large part from the choices you make between now and then. And one of the most powerful of those choices is the decision to stop feeding it, the one substance most consistently shown to accelerate its decline. I am Dr. Marcus Reid. I will see you in the next one. This content is for educational purposes only and does not constitute medical advice. Always consult your physician before making changes to your diet or health routine.